Here you go. I hope everyone can see it. So, good evening, everyone, for the people who are in Japan. For me, it's morning. I'm in London, so it's 11 o'clock. I just wanted to say, please don't hesitate to enable the subtitles in Zoom. They call captions at the bottom of your Zoom screen in case you don't understand my accent or in case I don't speak or I speak too fast or not or too slowly. Right, so this is the agenda for today for my presentation. The goal of these presentations are to explain the Google Core Web Vitals and their importance in the context of e-commerce website performance. So my main subject here is going to be front-end performance testing in the context of microservices on an e-commerce website and talking about the Google Core Web Vitals. So I will describe also how all our microservices team were mobilized to continuously test and monitor their Core Web Vitals. And at the end, I will give you a practical example of a Teams testing and monitoring process for the Core Web Vitals. So who am I? So I'm French, and I've lived and worked in London in the UK for over 25 years. I have over 25 years of experience in quality engineering, mostly in non-functional testing and in the financial services. I've been in my current company for over 4 years, with the last 3 years in a delivery role. I'm a lead for my company's quality engineering community of interest. And since I'm passionate about performance testing, I'm also a front-end performance testing champion. Let me tell you now about my current company, John Lewis. So John Lewis is one of the largest British retailer with two brands under its hat, John Lewis for the department stores and Waitrose for the grocery stores. So I work for John Lewis mostly, the John Lewis part. And our John Lewis website is hosted on the Google Cloud platform. We have a microservice-based architecture and a Devops operating model. Each service team uses automated CI/CD pipelines to build, to test, to deploy, to monitor, and do incident management. And to give you an idea, last year we have deployed over 12,000 changes on our platform with a low failure rate of 0.04%. So in a way, we're like a mini Amazon, but we don't like referring to them too much because they are our competitors. We have also 40 different teams managing over 90 plus services and 500 plus microservices. So what are the Google Core Web Vitals? Quite a complicated names. Even I struggle with pronunciating it. So there are three important metrics that assess how quickly and smoothly a website loads and functions for its users. Each of the Core Web Vitals represent a distinct facet of the user experience. They have been defined by Google. Everyone can access and check them, and they are part of Google's effort to make the web a better place for its users. They are not a direct source of income or revenue for Google. And the core Web Vitals are a subset of the Web Vitals. They have become the reference to measure front-end web performance on most e-commerce websites like ours at John Lewis. So now I'm going to describe the three core Web Vitals. The first one, largest contentful pane, is about page loading speed. And it is calculated by measuring the loading time of the biggest image or text block on a page. which is often the hero on that page. Then we have INP, which measures the interactivity of a page by measuring the delay between the worst user interactions and the first visual change on the screen in terms of the browser's response, so the next frame painted on the screen. And lastly, the cumulative layout shift is about visual stability. It's about how much a web page content moves and shifts around as it loads. So it's a very annoying thing when that happens to users. And those core web vitals evolve constantly. For instance, in March, 2 months ago, in March 2024, the interactivity one changed from FID, first input delay, to INP, interaction to next paint. You can check more details about those on the Google Web Development website. The URLs are on the slide, web.dev/vitals and web.dev learn core web vitals. I strongly advise that you have a look at them in order also to understand what client-side and front-end performance testing means, which is a very different thing from what a lot of you might be used to, which is load testing. We're not talking about volume testing here. We're just talking about the client-side performance of a web page. So why are the core web vitals so important? They are important for a few reasons. First, improved user experience. So when a website is quick to load, is visually stable and fast to interact with, basically when it has good core web vitals, then the users are happier and more engaged. And this can lead to increased time on a page, lower bounce rates, and higher conversion rates. Then improve SEO. So SEO means search engine optimization. So Google has made the core web vitals a ranking factor in Google search. This means that pages with good core web vitals are more likely to rank higher in search results, which can lead to increased traffic and revenue. Then improve brand reputation. So a website with good core web vitals is more likely to be perceived as being professional and trustworthy, and this can lead to improved brand reputation and customer loyalty. And lastly, standardized metrics. So the core web vitals are a standardized set of metrics that website owners can use to measure their site's performance. This makes it easier to compare performance across different websites and identify areas for improvement. So all of the above combined lead to increased traffic and revenue. This is why at John Lewis we have a key focus on those metrics, and we aim at achieving the best score possible for the core web vitals. So briefly, I'm going to explain to you or talk about how we manage to engage our 12 plus front-end teams. So front-end working with user interface, our front-end microservice team, how we got them engaged with the core web vitals. So we have a centralized service team responsible for the stability, performance, and resilience of our website. I will call them the platform team. And the platform team decided to make the core web vitals a priority and came up with an approach to rally all the teams around them. The approach was implemented was focused on 3 areas. The first one was about communicating about the importance of the core web vitals and how to monitor and test the core web vitals using the new tools that they would provide. This was done through talking at communities of interest internally, internal town halls, and using Slack, our chat tool, and via centralized dashboard. So I played a role into this. I played back their presentations to my testing community of interest internally. I also gave demonstrations of the various tools one can use to test the core web vitals, including the tools provided by the platform team. I paired with other product engineers to explain how to test and monitor the Core Web Vitals, and I keep providing regular updates on the Core Web Vitals and the new tooling available for that. So I'm still doing that today in my quality of a front-end performance champion. The second area was for their approach was challenging. So the platform team decided to challenge all the front-end microservices team with publishing a leaderboard called the Lighthouse Leaderboard in a centralized place accessible to all. So this is an example of that board at the time, and the board shown here shows each microservice team Core Web Vital score on the top tiles at the top here with more details underneath. The idea of that leaderboard dashboard was to appeal to teams' sense of competition, but above all to appeal to teams wanting to do a good job. And the last area for the approach was the tooling. The platform team customized and made available existing open source software for all our service teams to use for testing and monitoring the Core Web Vitals. The tools are easy, if not automatically implemented in each microservice, each micro project. They are integrated with our central dashboard tool, Grafana, and accessible by all, and they are also integrated with Slack for alerting. You can see here the names of the tools above in the slide for reference. I'm not going to go into too much details, but the main one that we use constantly is the one called Web Page Test, and you can find it on the internet and have a look, even enter the URL for your web page or website and see how well you score on the Core Web Vitals. So what were the key challenges faced with this approach of trying to rally all the microservices front-end teams into using the Core Web Vitals, monitoring them constantly, and making sure their scores were very good on the Core Web Vitals? So first, the challenge was getting traction. In order to get traction quickly on the Core Web Vitals, the platform team decided to focus on the product engineers, the engineering community. And it is only later on that they started focusing on business analyst, delivery lead, and product manager or product owner. Secondly, in order to not just engagement at the beginning with the big buzz around the communication campaign, the platform team started running checks on the microservices team's Core Web Vital scores and sending or posting in Slack, that's how we communicate internally, sending gentle prodding when they would note a significant regression or issues with the Core Web Vital scores for that team. And thirdly, the tools had to evolve over time to be more accurate and better integrated with our systems and ways of working. So the tooling approach wasn't quite right at first and had to change. That was the third challenge the team had to face. But in the end, this all paid off. So to give you an example, we have our own UK competitors website leaderboard where we compare our Core Web Vital scores against 125 UK competitors. And today, on mobile, we rank in position 23. To give you an idea, Amazon ranks in position 35. And on desktop, we rank in position 17 for the Core Web Vitals, and Amazon is 51. We used to rank much higher before they changed the interactive value, the INP value from FID to INP. Even Amazon used to rank higher, but this one is a very hard one to get better at. Now let's move on to a more practical part of my presentation. Hopefully it will sound a bit less theoretical to you. Rather than using a change or a new feature as my starting point and explaining how our front-end performance testing process, I will describe the steps that we went through following a front-end performance production bug. So I choose a bug which had to do with one of the core web vitals, the third one that I explained to you earlier, which is called CLS, the cumulative layout shift. And I will explain the process around detecting the issue, the bug in production, fixing it, and then testing and retesting it. On the slide here, on the left-hand side, you can see our mobile homepage at the time of the issue of the bug. So we had just added an old component as the hero on it. The hero here is that picture at the top, which has a sofa on it and has a little cross on it with a little pop-up window. So that component in my team is called the hotspot component. So it's my team who's responsible for creating components for the editors to use on the homepage. And that hotspot component is basically an image with a hotspot, so that little cross you can see here, on which users can hover on with their mouse or can tap on when they're on a mobile device to view the product details and the price, and then they can click to get taken to the product details page and hopefully buy the product. What happened is that we got an alert in our Slack channel telling us that the CLS, the cumulative layout shift on the homepage, had increased by 1,500 plus %. And that it was in the red. Basically, when the CLS is above 0.1 in terms of scoring, it's red. And ours was at 0.3. And just a reminder, as per my slides earlier on the Core Web Vitals, the cumulative layout shift is the Core Web Vitals, which measures the visual stability of a page. So in other words, it's how much a page's layout shifts unexpectedly as it loads. Things move around basically when the page loads. So we got the alerting in my team, in my microservice team, telling us that we have a bug with CLS on the homepage in production. What I did is I went immediately to check that the information was correct, and I went into one of our tools provided by the platform team to us, which is called the web page test tool. And I went to that dashboard, which shows the CLS, the cumulative layout shifts. And you can see here that it had moved from 0 milliseconds to 0.3. Then I checked for more details in the web page test tools, so you can drill down basically. And I could confirm that Core Web Vitals was also in the red. You can see the other Core Web Vitals here. You can see the LCP, for instance, it's in green, but the CLS was in red. And lastly, I decided to perform some visual checks on the home page. So to see if I could see the CLS, as the CLS, the cumulative layout shift, is something visually noticeable. So I basically applied some network throttling in my browser using the dev tools to slow down the page loading and to see what happens. And you can see here on the left-hand side that at 40% loaded of the loading time, the hero top, you know, that part with the sofa is missing. And then while the page keeps loading, eventually that hero appears, which is that hotspot component. But then when it loads, it shifts everything down. The rest of the page is shifted down and it creates a visual shift. Everything is moved around. This is what we call CLS. And as a note, the CLS, cumulative layout shift, is a lab metric which can be measured in any client browser and will always give you the same score. So I got confirmation by using the Lighthouse tool from the DevTools locally in my browser. The Lighthouse tool is available to everyone. If you check your DevTools in a Chrome browser, you will see the Lighthouse tool, and you can monitor. You can basically measure that CLS score and some of the other Core Web Vitals scores or the Web Vitals. I ran also some. I got more details as well. I used some filtering in the Lighthouse tool to pinpoint the cause of the CLS and do some root cause analysis. And this confirmed that the hero was responsible for the shift. And you can, I will share my slides anyway, and you can have a look in more details at everything that I've put, all the information I put in the slides. So I discussed this with my team. We decided to raise a bug after discussion, and we went on to try to understand the cause of the issue. And the reason, the cause for the issue was that the hotspot component, so that image with the little cross, was not passing its dimensions or aspect ratio to the browser. And therefore, because of that, for that reason, no allocation of space was made by the browser for the hero while it was loading the page, because the browser didn't know how much space to allocate for that hotspot component or hero. So what we did quickly in our microservice, I went to talk to the people who edit the home page, because my team is responsible for the technology behind the page, but not for the edition. And we decided to replace that hotspot component with a standard image component. And we knew that that image component was passing its ratio to the browser, because that's how we developed it. And I went on to recreate the problem in our test environment with creating a test page using the hotspot component as the hero. And you can see above or here in the slide that the same shift is happening in my test page. So on the left, while it's loading, it doesn't reserve the space for the hotspot component. And then eventually at some point, the hotspot component appears, but then it shifts everything down and there's a visual shift happening. And we deployed that test page in our test environment. Once I deployed it, I could see the cumulative layout shift going up, the score going up. We deployed a fix to the component so that the component could pass its ratio or dimensions to the browser. And you can see on the right-hand side, as soon as the fix was deployed, the scoring for that page just went down to 0 in terms of CLS scoring. And now that this is how the page loads after applying the fix, so at 47% loaded, basically while the page is loading, the page knows the dimension of that component and has already reserved a space for that component. And then once the component is loaded and is ready to appear on the page, it's using that space. But what it means is there's no visual shift happening in the page. That's all of this happened very quickly. It's very hard to see, the white space. It's almost immediately you see that image. But if the space is not reserved, if there's a shift, you can definitely see it with your eyes when things move. And we deployed the fix in production. So this is what happened in production after deploying the fix, and you can see that there's a space reserved at the top of the page, and then the hero component appears in the space. Everything then was confirmed by retesting. So I retested locally in my browser using another tool called the Web Vitals Chrome extension. and I could see the score here, the cumulative layout shifts set at 0. I also confirmed, this was also confirmed by our web page test tool instance, which we have in production. And you can see here in the middle that the CLS is gone back to 0. So basically, that's the story behind that bug. And it was a success. We managed to fix it, to identify it, fix it very quickly. And yeah, I guess that's it. So thank you for listening. I hope you found it interesting, not too complicated. I hope that you feel you've learned something. By all means, do check about the Core Web Vitals. If you have a website that is an e-commerce website or a website for which the front-end performance or user experience is important, and learn a bit more on how to monitor and test Core Web Vitals. And now it's question time.